Hello. Another pair of Skunkworks puzzles. Match up 5. And back on to having the pair of puzzles to have to decide the winner. Normal Stoker's normal, and then we've got equal lines. So any line of the same colour has the same sum. So all the greys add to the same thing with this little handy dandy note taking thing for be able to see that, and then all the reds sum to the same as well, which is going to be quite big. Get it? And then finally we've got x sums, so digits outside the grids are the sum of the first x digits, with absolutely no clues outside the grid, which I realise in number clues, which I rather like. Just ones coming off the lines, which is going to be interesting. So this, I mean, it feels like it should have quite a small range, but that's actually quite big. But oh yeah, no, we can't be 30, can we? Just thinking of maximums and minimums. That's probably what I'll put in here to start with. Can't be 30 or else those two share far too much. And what's this as a max? Trying to work out how to minimize this. That can be 1, 2, 3, 4, and that can be 1, 2, 3, 4. But this can't, can it? Because oh no, yeah, it can. What am I on about? You could look like this, couldn't you? Put on 4. Yeah. Oh no, but the whole point, the point is like, because that's minimum 10. That'd be 1, and that's then minimum 1, 3. But that's as small as you can get, isn't it? 10, 17 is an absolute minimum, and the maximum can't make 28, 29, or 20 or 30. So that's at most 28, which you can do in a couple of ways. And red's a bit more restricted. It's at most at least 15 and at most 17. Let's get rid of that. So then the question is, what are these doing? So this can't be that big, can it? Like, it can't be a 7, because then that would be a 28. So that's a most of 6, but it also isn't going to be that small. Like, that can't be a 1. 2's way too small as well, isn't it? Because sort of what you're saying is the sum of this line is 2 lots of that, add however many things that you have. So if that was like 2 2's and a 9 would be way too small. And yeah, here's something interesting. So the grey line sum is equal to 2 lots of green plus some amount of pink, and it's at least those 3, and could be more. But what I was wondering about is if this were 3, and there's 6. 6 isn't too big, is it? I'll be 6 with 1, 2, 3, 4, 5. 21, 27. No, that is okay. But there's, yeah, so oh nice, I can write down here if I need to make some extra notes. So grey is equal to 2 lots of green, add some section of pink, which might only be these 2 digits, but surely that's not enough. I was just thinking, yeah, they both, yeah. If one's 3, the other isn't, but I don't know how much that actually does. Oh, and grey, because red isn't that big, is grey quite restricted with this line, perhaps? I wonder. Hmm. Metal pencil mark. In fact, I don't think that can be a 6, can it? Oh, it can with a 1 here. Yeah. Oh, and of course, no, this can just about be. No, 28's way too big with this 15, isn't it? I'm pretty sure. Because if they tried to be 2 lots of 28, basically that's at most 70 in total. So these cells selected are most I'm trying to say most 65 and most 64 because you got that. Oh no, most 54. So that's 27, but it's not a big thing. But it does get rid of the 6 because 6 had to put 21 and then like a 1 there, which is too much. And of course this could be bigger, but that makes that smaller. Yeah, so just thinking about these cells, because of course neither of them can be 7 either. And the grey line's the sum of, I suppose these aren't, are these two, they're only counted once, aren't they? Yeah. So the grey line is the sum of that plus some amount of this plus some amount of that. So, I mean, if neither of those were 1s and 2s, but not really. Try and say that. These 2 cells, of course, have to go here. They can't go on the red line. That's by the by. This must be doing something. So grey's equal to 2 lots of that plus some section of pink. And that's exactly equal to, actually, let's make that like that. That makes the grey line a bit hard to see. That'll do. 2 lots of light blue and some amount of dark blue. Don't know how much at the moment. Because what I was interested in is I know grey is also equal to the pink selected cells here. So, for example, just wondering if you get rid of 5s. Trouble is, I don't. These are quite independent. Let's think about 1 at a time. Perhaps. Because if this was a 5, and then the logic holds up the same, because it's all just symmetric. In fact, what does? Oh, that's quite. That's be like, what does disambiguate it all? But there's quite a lot that will do that for you. Fives here. Fives here, but minimum of 20 there. So that would be minimum 25. No, sorry, minimum of 15. So that would be minimum of 20. Just does work, doesn't it? You'd have a 5 and a 1 and a 1. Lots of 6, 7, 8, 9s. Right, let's go back to this, because this is where you have the most interactions of stuff that overlaps, if that makes any sense. So if this is a 5, right, what that implies is, because you can just cancel any cells that overlap. And in fact, I can cancel those straight away. Should be dark green, shouldn't it? Because I know these definitely exist. So say that was a 3. The point is, yeah, that doesn't work, does it? If that's 3, then your equation of this is just 2 lots of that plus that. Cancel those. Those would have to sum to even 6 even, which is way too small. So that's definitely not a 3. Likewise for that one. Yeah, they can get away with being 17s, can't they? I think. So I can cancel at least that as well. And if that was a 4, and I've now cancelled these cells, then those sum to 8, which is a minimum of 9s. They're not 4s either. So I can cancel that. So either this sums to 10, or you get an extra green cell here, which won't cancel anything. And I know I was about to say at least one of these had to be 5, but we don't know that has to be 15. But the minimum has increased by a fair bit. That's now at least 20. At least 20, does that say anything? Yeah, surely this can't be that small anymore. 2 feels like way too little. Oh no, because you can make like 17 here if you wanted. Sorry, what am I trying to say? 2, 9, we put an 11 or whatever, which would be 13 and then a 7. Yeah. So it isn't. I was thinking you had loads of degrees of freedom if that was a 2, but you've got some anyway. Can they both be 5s? What would that imply? That would imply that both pink and make it symmetrical yellow sums to 10. Should be fine. I think. Yeah. So that's good. Got those down a fair bit. And 6, so 6 does force 27 exactly, doesn't it? Because 5, you've got a bunch of freedom. But the 6s do imply 27. Which, interestingly, means this can't be... What am I trying to say? Oh, no, look at this, right? If that's 6, then that has to be 1, 2, 3, 4, 5, 6. This is a 7, 8, 9 triple. That's no way going to get to 27, is it? Yeah. So that's definitely a 5. We have a digit. We have a double. Yeah, sorry. So that means these cells sum to 10. So these sum to 9 at most. Doesn't do all that much. And It's sum to 10. I don't think we can do the same thing with this. If that's a 6, right? Then what does that mean? That means that those cells sum to, yeah, to 17 or whatever. I mean, there'll be a lot going on at that point, wouldn't there? If that is a 6, that would sum to 17, 22, 20, leaves 23 behind. And these would, of course, be 27. So that could be at most, what, 15? It does just about work, doesn't it? With an 8 or a 9. So if this is a 6, then you're forced 27. And then this is either 16, 15, or 16. And can it... Oh, hang on a mo. No. If that's 27, I don't think these work. Because one has to be a... Oh, no, the point is that would have to be 15, wouldn't it? One of these would be 4... 27. No, that is okay. 3, 7, 8, 9. How do you make 27? 3, 7, 8, 9. There's loads of ways to make 27, isn't there? 4, 6, 8, 9. Because you can do that, can't you? Yes, yeah. But that would, if that is 27, that does have to be 15, doesn't it? Looking at what would be left over. Because you're always taking a 9. So interesting, if that's 6, that's 7, 8, and this is 1, 2, 3, 4, 5. So you got a 5 somewhere along these 3. That helpful? If that's 6, that's minimum 21, but then you're not exactly needing to pick up much here, are you? But is it the same there that... but no, that's probably fine. So 6 is exact. That's 1, 2, 3, 4, 5 along here. And implies that that sums to 17. Random thing that... Oh no, that can be 6 with 1, 2, 1. So 6 implies this sums to 15. Six implies 7, 8. And implies that this is 1, 2, 3, 4, 5 as well. You wouldn't struggle to get up to 27 with just using 1, 2, 3, 4, 5, would you? I'm pretty sure. I think that would be fine. That surely can't be a 1. No, that's then minimum 11. So that's kind of small, but I'm pretty sure that's just going to be a disambiguator, isn't it? I was about to try and do the exact same logic that I've done to make pink sum to 10. If that's 4, that's 1, 2, 3. Probably doesn't mean anything, does it? If, hang on a mo, if this is 5 now, then what happens there? That's 5. Then no, because you could be quite big still. That's big. Oh, here's something maybe. That, of course, if this is 5, we're already at 16, and these definitely need a 9. So, what's your maximum there? It's 26, isn't it? So, if this is 5, gray's at most 26. But is that really saying anything? Oh, can't I do more of this as well? I think I'm really gonna have to do some interesting colouring here. So yellow sums to 45, right? Because what I was wondering about is where we're going to hide orange cells. Because they can't obviously all go on here. But can you get... And we know, hang on. Right, let's ditch these colours. We know, of course, that orange is equal to green add 10. That's true, isn't it? Yeah. Orange equals green add 10. And the reason that's interesting is orange is one of these, isn't it? Yeah. So orange is somewhere between 20 and 27. So green's going to be somewhere between 10 and 17. If it were 10, then these are 1, 2, 3, 4, right? Should be able to bump this up, surely. Just realised I could place another digit if I want to. Because this is checking on the pencil mark, so that's a 2. And I could make that, but I'll leave my notation for now. What am I trying to say? 1, 2, 3, 4. Because that puts 6, 7, 8, 9 quad here. That could be like 5, 4, 3, 9, which is plenty big enough. Could be 2, 2, 4, 5, 9, or 3, 4, 5, 8. But here's something interesting, maybe. So I've said as soon as this is a 5, then we can't be 27 anymore, can we? Because this is at least 16, and one of these has a 9. Yes, that's true. So either this is 6, and this sums to 17, and that's a 7, 8, 9 triple. Or, and also like these are 15 and whatnot. Or this is 5, and then this sums to at most 16. Going for a big equation here now. Now I've used orange. So this is going to be fun. Shimmy, let's shimmy you over here. It's green, add 10. So I know 45 is the sum of light blue, dark pink, and orange. I know 45 is also, let's write those. Try and keep this vaguely consistent. Oh, I've got 4 colours now over here. No, well, I could take off that 10, that 5, can't I? Let's just call it 40. Don't really need the yellow. Is the same as green, add red, add blue. If this does nothing, by the way. What shall I cancel? Let's try and get rid of green first of all, maybe. So you end up with what? 30 add orange is the same as red add blue. Just doing that one minus that one. No, sorry, that's 50. That minus that, just chuck that over there. Or just, yeah, just substitute what am I trying to do? Trying to do that minus that. Yeah, so you get minus, yeah. The orange is on this side. Point. It should be anyway, shouldn't it? I should really write this down, but done that minus that. Chuck that over there and chuck that over there. Yeah, we're fine. We're fine. So then I want to do that minus that. Which is gonna give quite a lot. 5 add pink is red. So 5 add pink is red. So that's quite big and that's quite small. Five add pink is red. Right. Well, I think that all made sense. If I've butchered something somewhere, I wouldn't be that surprised, but that hopefully made sense. So, it's not really done anything. It's made one of these be at least a 4, so can that be a 5? No. And that can't be a 5 either. Can either of these be 4s? Because that's at least 6 now. And ones go along here, don't they? In fact, both of purple cells go along there. This still seems fine to be a 6, I think. 6, 1, 2, 3, 4, 5. One of these has to be a 2 or a 3, doesn't it? Yeah, that can't be a 4, 5 pair. How much? Oh, you got 1 degree of freedom between. Because pinks, we know 7 to 10. Yeah, there's 2, 3 there. So, like, I could get rid of 2 and 3 from all of this. What does that do? Not all that much. 6. It's 1, 2, 3, 4, 5. It's 1, 2, 3, 4, 5 down here. Feels like there should be some sort of triple that's gonna mess things up. A triple might be pushing it. It feels like it's going to be more digits. Use your brain. Red drops onto here. There must be. No. Yeah, 5 and red are on there, aren't they? Yeah, I definitely feel like I could have seen that without doing quite as much as I did. I don't know. So, I do keep going back to these options, but I also feel like I've kind of exhausted them at this point. Yeah, exactly. One of these is 2 or 3. But that can be 3, 4, 2 if it wanted. And also, this can happily be a 5, can't it? You could have a 5 here with 6. That would be 1, 2, 2. And then a 3, 4 pair. Five and 2. Does that actually work? Yeah. Yeah, no, that's fine. 20, yeah, 27 with a 5. This must be getting closer, surely. It also doesn't feel like I've managed much in the last while. 6. So if this was 5, then we get the same thing of the pink cells, don't we? That these have to sum to 10. So they'd come from 1, 2, 3, and 4. So need a 1. And that's 10. This is thinking about if this is a 5. And this needs a 9 somewhere, as does this. Does that help? It couldn't be 2, 3, 4, but it could be 1, 3, 4, or 1, 2, 3 with a 4 here or whatever. Surely this doesn't actually do anything, does it? It's just got to be a disambiguator near the end. That's because I might be able to get rid of a 5 or something from it, but 20 ads. Yeah, no. Plenty of leeway. Do I want to make the pencil mark that I've got 5 somewhere here? Not particularly, admittedly. Oh, of course, as soon as this is 6, then because we've said that as soon as that's 5, you're less than 27 on grey. That would have to be a 1. That's 6, that's 1. Yeah. Like a 2-3 pair. I was wondering about if these cells weren't allowed to be small or something. That seems alright. I mean, I can rule 5s out of here as well, because of course either that's a 5 or that's a 6. 1, 2, 3, 4, 5. Nope. Thought I had a thought. Apparently not. Oh, yeah, but 2027 can be made in so many ways, can't it? It just always needs a 9. That make that? No, not necessarily 9. 6, 1, 2, 3, 4, 5. And therefore that sums to 17. 22, yeah, 23 here. 27. And that's just to do with that relationship. Or if 5, then there's got to be a 9 always here, here, or here. That probably can't be 2 at that point. It's counted twice, plus these 2, but you could still be pretty massive. Yeah. I am stumped. These puzzles have definitely gotten tricky. Because I can't, sort of going back to this cell, wondering if I can say literally anything about it. If that's 6, it's less than 4. It's 1, 2, 3, or 4. Well, it's 2, 3, or 4 even, but in the case that it's a 5, then all I know is that sums to 10. I don't think that says anything. Hmm. Right, 5 more minutes, and then I'll have a break and tackle it again tomorrow. But they're done with another big grey line down here. 6 here. Forces that to be 7 and 8. Forces this to be 1, 2. Oh. Is that more interesting than I thought? 6 here forces 7 and 8. And 1, 2, 3, 4, 5. So I have to write this down. 6 here with a 7 and 8. Keep going. 6 here with 7 and 8. Put a 5 somewhere there because that would have to sum to 15. Isn't that problematic because of this? That would put... Because that needs... both of them need a 9. This would be a 7-8 pair. So this would be at most... Oh, you know what? It just works. The 4's down here. That forces a 4 up there. Drops a 4 down here. 7, 8, and 9 with a 1, 3. That puts a 2. That's not the direction I wanted that to go in terms of freedom that it had. Can I really not see anything that breaks here? 4, 9, 6, 8. 7, 8, 9, 1, 3. Oh, 5, 9 is 14, needs 13 more, doesn't it? So that would need, that needs 6 and 7. Ew. It all works. It all works. 5, 6, 7. 5, 6, 7, and 9. With 8. And what would that be? That would be a 2, 4 pair. 2, 4, 8, and 9. Leaving 1, 3, 6, and 7 along here. Which, of course, sums to... Yeah, it does sum to 17, doesn't it? 1. And 1, 3, 6, and 7. I mean, it puts a 1, 3 there. Gives you a 2. Oh, I don't think that is. The good news is, if that is a 6, I've got a lot of the next logic part, haven't I? So, in the last minute or so, let's have a look at what happens if this is a 5. Because that could be interesting. If this is the 5, this is at least 16, and that's got to have a 9 on it. I couldn't roll a 9 out of here. I managed to do that early on. What am I about? If this is a 5, and we know we've got a 4 here, and this sums to 10, comes from 1, 2, 3, 4, definitely uses those. Sorry, hitting the mic. And that would, if that's 5, And this is either 1, 2, 3, 4, 6 or 1, 2, 3, 4, 7. Does that mean anything? Not that I can see, really. No. Yeah, again, it all just seems to just about work. Surely it's not anywhere else, is it? Right, I'm going to leave it there for today. Yeah, as I say, I'll come back to it another time. I won't have a look at the next puzzle yet, in the hopes that I solve them back to back to make it easier to give feedback. Probably won't share this, but if I do, it'll probably be an extra part if you're interested in 45 minutes of rambling. Yeah, if that's the case, thank you for watching. Chat to you later. Bye. So of course, I stopped the recording and then immediately spot what I've been missing for like the last half hour or so. So apologies for that. I probably will stick this one on the end, so I won't like stick them together. I won't run through everything again. So I think what I saw, let's make sure I do actually notice this, do this properly. If this is 5, right, then this has got to be at least 16 or 17. Therefore, this needs a 9, and one of these is at most 26. The problem with that is these two. These two point down into this box, which I should have seen. It's yeah, that is far more telegraphed than how long that should have taken me. So the problem with that is, with these both being at least 16, you get at least 16 added on here. These have a minimum of 1 and 2, and then you're going to be counting this cell again from the exams on the outside here. So the minimum is 16, add 1 and 2 for 19, add another 1 for 20, and then on the outside, oh, I miscounted when I wasn't recording. I thought it was exact, but in fact it's 29, isn't it? So that's obviously way too big. And oh, so can't you just do that straight off the bat? If red is 16 or 17, then it forces that to be at least 16, which is way too big. So you don't even have to do any of this nonsense. Oh, dear Lord. Right. So this is 15. Meaning we get 5s up here, this is a 6, and this is 27. I'd like to apologise for how much I've butchered this. Oh, dear Lord. So that's 1, 2, 3, 4, 5. That's 7, 8, 9's here. What else do we know? That's 7, 6, 7, 8. And these both need a 9, so this is also a 7, 8 pair. Don't know how that looks though. So these, oops, these don't come from, or 4, 5, yeah, 5, 5, 6, 7, and 8 already used up in the row. 27, that's got to have a 9 here, and because of this, you're already at your max. Like that has to be 6, 8, 4, 9 is the sum to 27. So this needs Definitely needs a 9, obviously. We're at 14. We need another 13 without 5, 9, or without 4, 9, or 5, 8. So that's 5, 6, 7, 9. That's 9. So with my bit of early maths, at least that's a 1, 3 pair still. That gives a 3 up there. 1, 2. And these sum to 7 because of this. Which works with 2 and 5, luckily. I had a moment there where that didn't look like that was going to happen. Get rid of 4s. 4s are down here now. It's not 2, 3, or 5. There's a 4. Anything else? 6s. It's not a 2 now, look. Get rid of my colouring. 7, 6, 8, 9, triple in the row. What are these? These come from 1, 2, 3, and 5. As does that. You get 1, 2, 3. 1, 2, 3, 4 triple. So 6, 7, 8, 9. Definitely 9s. These two cells are the same. It's nice that you get so much once you get into this. So you spot the glaringly obvious. 1s and 3s in this row. Column even go down here. What sums do I need to make sure I've got? It's 21. That's 17. Do I mean 17? 27. Yeah. That's 22. We got there eventually. This I might be able to do something with. Can I? Can that really be a 5? Picking up all of this. Minimum of 6, 7, 1, 4, 10, 23. Yeah, that's okay. Does this do anything? Oh, 4. Yeah, 4s are here, aren't they? Which I think I did know. If that's 5, right? Ah, no, but that's got so much. Oh, 4s are down here as well. And what else? They're not 6. Definitely have 2s and 3s along here. I can probably rule out that being a 3. That would be... Oh no, that's fine actually, because that's 7 and then that's just 8 or whatever. Where else am I meant to be looking? 8's here. Nice if that had to be a 7, 8 pair. If this is 7 and 8, is it the exact same problem as before? This would be 15, 18, 19. Add another 2 and 7. Add another 9. Sorry, 15, 18, 19. Would need another 9 minimum. 18, 19, 28. Oh, I could not do the maths then. So that is definitely 6, which gives you so much. And then stops. 9s. That's the next. I mean, they're not sixes now. Sixes down here. Really not going to give me anything else? Apparently not. That's a 3. You don't get too big, do you? I mean, this would sum to at least 12. In fact, even bigger than that. That's 3, then that's at least 13. And that's way too big, so that is 2. Which does a bit of that. And this is now either 5, making 7 and 8, which it has to be, doesn't it? Because if that's like an 8, then that would be 10, and that's way too big. To get 3, 5, this 7, that's 8. So 8s are here. 7, 7, 9. 9s. Can 9s go here? Probably not for the whole reason of this. 17. I've done this sum so much. Oh dear. 9's there. 7's up top. Yeah. Any more easy bits? Not that I can see. Surely this can't be that big. All that 5. We're already at 1, 2, 6, 8. Or actually, if I rule out this one being a 5, that's probably the easier one to actually see anything. There's a little quad as well, isn't there? 2, 4, get rid of 5. There's a 6, 7 pair, and we can do that. Leaving 1, 3, 5 up and down here. And that does have to be 2, unsurprisingly. So this is 10 on the outside there. And we've got 20 so far. So we need another 7 at most. That has to be 1. That's also 1. That's 5 and 3. That all works. I like that. 1s, 3s. 1, 3, 4 leaves 6. Yeah. 6 and 4. 1, 2, 5. This to finish it off, maybe? Because this is either sum of pink add 2 blue equals 19. If that's a 3, which is way too small, isn't it? If that's 3, then that's 11, and you need another 16. So these 3 would sum to 16, so those would have to sum to 13, which it's certainly not doing. Looking at what we've got left. So that is a 4. So it's a 1, 3. We can do those. I'll have 7s there for ages. I don't know. So that's 12, needs 15 more. So these sum to 11. If that's 1, that's way too small. 8, putting 1, 2, or 7, I think 1, 3. Oh, and we got a 2 there, so that is a 3. 7, 8, 1, 7 and 9. That puts an 8 there. 9, 9, 4. So this is, let's just double check it. That's 15. Perfect. Threes and 4s and 9s and 5s, that looks like. 2s here, 2s, 1s. not necessarily 1. So it's going to be this that finishes off. I can't believe as well, because I sort of looked at that earlier. I was like, oh yeah, no, that sure isn't doing much, is it, at this point? If that's 5, that's now way too big, because this is already 21, 26. That's 2, 5, which gives us all of these. And then that probably can't be a 4. Maybe it is a 4, actually. 4, 18 minimum, and another 8, 26. That does just about work with the 1 up here. We don't have any other patterns or anything, I don't think. So maybe this can't be a 3. That's 3. Oh, either way, that's always 1, isn't it? Which might actually do it. If that's, let me just double check the maths. If that's 4, that's got a minimum of 18, and another 8 is 26. That would have to be a 1 to make 27 for the line. Yeah, that doesn't do that much because you're still left with the exact same 3, 4, 6, 8 thing. But if this is 3 now, then that's either 16 or 18. And 16 or 18. So if it was 16, then this would have to be 10, but that's 2 and 6. If it's 18, that would have to be 8, but it's 2 and 8. So that doesn't work. So this is 4. 3, 4, and then that needs the 6, doesn't it? But 8 here, 18 there. That sum works. 8, 8, 6. And a 1 and a 3. Very nice. Well, once I realised what was going on, of course, you immediately spot it once you decide that you're stopping. Yeah. Very good puzzle. Right, let's try 5B and see how we get on with this. So quite a different approach. More equal sum lines and just the same sum lines, and then actual digits on the outside, which is very exciting. Let's see if I remember much of my X sums. That can't be a 6 either. So that's either 4 or 5, 23, 22 even. That can't be 3, can that? That's 4, 5, and 6. As are of these, aren't they? Yeah. Oh, and of course, this sums across to 25. That's going to be the same in a lot of places, isn't it? So these are 4 5s, these are 4 5s. There's a 6 down here. And what does that say? So these don't sum. So one of these is a 6. And how much do they go over? Only by 4. Oh, so that's really cool. If this was 6 and 4, I know one of these is a 6, so that rules out that. If that's 6 and 4, you overlap by a single cell, but that would be, the single cell would have to be a 4, so that is a 6 and 5, with these two being a 1, 3 pair, as that one's overlap. So what, that's 9, these sum to 15. So your equal sum line is 15 in this case. 15 and 30. Another 15 there. I don't think that means anything immediately. Oh, these are 7, 8, aren't they? 2, 4, and 9. That's not 4. This is 15. So if that was 5, and that does work with a 1, 2 pair. Or that's 15 and 4, which makes 19 and doesn't work because you'd need another 4. So that gives you all of this, and well, I've already broken the puzzle, haven't I? 5, 15, 1, 2. So I'm saying that has to be a 6, 7. That's making that too big. Oh, I shouldn't have tried to solve these this evening. This was a mistake. How the hell have I done? What on earth have I done? Why did I call that 50? So that had to be 5 and 6. And then this sum works, doesn't it? Because it couldn't be 4 and 6. So either of these can be a 3. So they have to be a 4, 5 pair. If that's 4, that's then 15, 19 needs another 4. Whereas 5, 15, 20, 23. Oh, it's because I really can't count, can I? That's your fifth cell. So if that's 4, that's just 19. I don't know why I can't count to 4. So that's 5, 4. That looks a bit better, doesn't it? This sums to 14. That isn't 5, 9. That's got to be 6, 8. 2, 7, 9 there. Sorry. 5 and 4 and 4. This 34 I didn't even include, did I? That's just got to be a 6, hasn't it? Yeah. Yeah. And these 3 sum to 11. Oh, and also 11 needed there. Does that help us with this 11? Not really. I mean, these 2 sum to that, but... 9 here does just about still work with 1, 5. And 2 would need 13 more, which always needs a 5, actually, doesn't it? Because it can't be 9, 4 or 6, 7. So that is always 5, and that's either 8 or 1. It's 5 somewhere up there. That was 4 and 2. And that sums to 15. Four and 2 means that sums to 15 and that sums to 15. Leaving a 1, 3 pair. But I think that's okay. 6 is the sum of that. That's 15, 21. That needs another 7. And surely we can just write this in, can't we? It's got an 8 on it, and it needs, yeah. That leaves 3 and 9, 1, 2, 4. Any of them? I don't think so, actually. 15, 30, 35, that needs another 10. It's definitely got a 1 in it because it's not 2, 3, 5, so that's 8 and 2 and 9. So then this is the 6, 7, 8, 9 with a 3, 1. Needing another 14 there, which isn't 5, 9. Oh, that's just straight up 7 and 8. 8 and 6. 1, 3 there. Let's try and press the right keys. If that's 4, then that doesn't get you there, does it? Nope. So that's 5, 8, 16, 22 needs another 2. Oh, so that was the 5. 2, 6, 7, 9, 7 and 9, 2 and 6 like that. 2, 3, 5. Not sure though. All right, and what this is? Sums to 15. If it had an 8, it would be 8, 3, 4. If it has a 7, there's no way that works, is it? Yeah. It's got to be 8, 3, 4. Also because of that. 7 and 2 and 4 and 9 to finish the box. That's not 4, so this isn't 3, 8 anymore. 9's there, that's not 2. 1, 3, 7, 8. Yeah. What we're left with 2, 3, 6, 8. That's not 1, that's not 7 either. There's a 4, 5, 9 triple, leaving 2, 8, and 6. A single there, 8s and 7s. Nine would need 1, 5. I think that's okay. Are there any other ones? I haven't finished this off yet, have I? And these two sum to 9, which only works with 4, 5. 9s and 7s. 4s, 4s, 1s. 3, 7. So that's a 5, isn't it? Oh, I was worried I'd lost my 7s in the box. Of course, they're down here. Where's the end of this? Oh, I haven't used this clue at all. So you got 6, 21, needs 4 more, doesn't it? So that's 1, 3, 8. Which gives you that one. And that means that can't be 9 anymore because we need 1, 4, 1, 5 or 2, 4. So that's 2, 9, 9, 6. 6s go here. And these two sum to 13, which has to be 5 and 8. 9. Oh, couldn't life for me see that. 2, 1, 1, 8, 7, 3. Nice. More straightforward, that one. Yeah. Very good pair of puzzles. Very different take between the two, with one just using standard X sums and the other jumping outside the grid. My vote is definitely going to go for this first one. Yeah, really good logic. And I should have seen this so much earlier than I did. Feel a bit took a long time, but that was very prettily set up with how that was then maximized, and then from there once you had the 6, and like the start of it as well was really pretty. This 5, like getting that first 5, yeah. And then it was nice as well once you did have that 6. It wasn't like it didn't entirely fall over. You still had to do a fair bit of work, didn't you? But everything flowed really nicely from there. Be interested how the others get on with this one. But yeah, lovely pair of puzzles, and I did still thoroughly enjoy this one. It was just less interesting interactions between everything. It was just do a bit of X sums and the equal lines fell out quite nicely. Interesting that you both ended up with the 15 sum. But yeah, lovely pair of puzzles. Thank you both for making them. Good luck to etc. 5. Oh, yeah, good luck to whoever makes it through. My decision's not the only one. See what the others say. But yeah. Thanks for the puzzles. Hope you enjoyed the video. See you later.